We would like to evaluate the tangent of 7 pi over 12 using half-angle formulas. But before we worry about a half-angle formula, let's first convert 7 pi over 12 into degrees. Starting with 7 pi over 12, we will multiply by 180 degrees over pi. The pi's cancel, and 7 multiplied by 180 divided by 12 is 105 degrees. The tangent of 7 pi over 12 is the same thing as the tangent of 105 degrees. 105 degrees is not on the unit circle, so we would not be able to find the exact value of tangent of 105 degrees. The half-angle formula is going to allow us to find an exact value because 210 degrees is on the unit circle. Tangent of 105 degrees is equal to the tangent of 210 degrees over 2. You are not asked to learn the half-angle formulas for tangent, but you do know the half-angle formulas for sine and cosine. So we're going to rewrite the tangent of 210 degrees over 2 as the sine of that angle over the cosine of that angle. We are using the quotient identity. Now we will need to find the answer to the numerator and the denominator. We will need the half-angle formulas for both sine and cosine. The half-angle formula for sine is as follows. The half-angle formula for cosine is this. Let's go ahead and focus on finding the half-angle of sine first. Substituting in 210 degrees for theta, we get this. Now we can go to the unit circle to find the answer to the cosine of 210 degrees, which will be the x-coordinate at 210 degrees. The x-coordinate at 210 degrees is negative root 3 over 2. Next, let's simplify just a bit. We can start by replacing the negative negative with a plus. Next, we will want to get rid of the fraction within the fraction. We can do this by multiplying the numerator and denominator by 2. Distributing 2 through the numerator and distributing 2 through the denominator, we get this. The square root of a fraction is the same thing as the square root of the numerator over the square root of the denominator. So we have plus or minus the square root of the numerator, and the square root of the denominator is 2. Now that we have found the answer to the sine of 210 over 2, we can focus on the cosine of theta over 2. Eventually, we will need to decide if the answer is positive or negative. The half-angle formulas say plus or minus, but it does not mean both. It's one or the other. But we will make that determination at the very end. So let's focus on the cosine of theta over 2. Here is the half-angle formula for the cosine of theta over 2. It's almost identical to the half-angle formula for sine of theta over 2. So substituting and simplifying will be much the same. Using this half-angle formula for cosine to find cosine of 210 degrees over 2, we substitute 210 degrees in for theta. Go to the unit circle to find the answer to cosine of 210 degrees, which is the x-coordinate at 210 degrees. The x-coordinate is negative root 3 over 2. We can simplify the signs. A plus minus will become just a minus. To get rid of the fraction within the fraction, we will multiply by 2 over 2, distributing the 2 through the numerator and the denominator. We have this. The square root of a fraction is the same as the square root of the numerator over the square root of the denominator. So we have the square root of the numerator, and the square root of the denominator, 4, is 2. Now that we have the answer to cosine of 210 degrees over 2, we have everything we need to find the answer to the tangent of 7 pi over 12. Again, we will worry about the positive or negative at the very end of the problem. All right, so we're going to take the tangent of 210 degrees over 2, which equals the sine of 210 over 2 over cosine of 210 over 2. It's going to equal positive or negative. We can make a substitution with these. Now to get rid of the fraction within the fraction, we can multiply the numerator and denominator by 2, distributing the 2 through the numerator and the denominator. These 2's cancel, and we get this. Now let's decide if the sign of our final answer is positive or negative. We've done a lot of work here, but ultimately we're finding the answer to the tangent of 210 degrees over 2. Which is the same thing as the tangent of 105 degrees. The angle 105 degrees is in quadrant 2. Using the acronym All Students Take Calculus, the only trig functions that are positive in quadrant 2 are sine and sine's reciprocal function cosecant, which means in quadrant 2 the answer to tangent is negative. Replacing the plus or minus with just a minus, I get my final answer. The half-angle formulas allowed us to find an exact value for the tangent of 105 degrees, even though 105 degrees was not on the unit circle. If you would have memorized the half-angle formula for tangent, we could have done this a little bit quicker. But sometimes memorizing too many things can make it challenging on a test. In this particular case, our answer would look slightly different than the answer someone would get using the half-angle formula for tangent, but they are the same thing. To verify, you could make both of them decimals and compare their approximations, and you would find that they are the same.